Hello everyone, here is a question based on mole concept and limiting reagent. When 81 gram of aluminium is allowed to react with 128 gram of oxygen gas, the mass of aluminium oxide produced in grams is how much? We need to find out the nearest integer. This problem involves 6 steps. First we need to write a balanced equation, then we need to write down the stoichiometric moles, then we need to find the moles of aluminium as well as O2. Then we need to figure out which one is the limiting reagent, and once we find the limiting reagent, we need to equate the stoichiometric moles of limiting reagent with the stoichiometric moles of product, and then we can find the mass of Al2O3. So let us first write the balanced equation. We have aluminium reacting with O2, and this will give Al2O3. To balance the equation, we put 3 here. Now we have 6 oxygen atoms. So that means we need to put 2 here. Now we have 4 aluminium atoms. Therefore, we need to put 4 here. Now the equation is balanced. Stoichiometric moles is, we write this way. Number of moles of aluminium divided by the stoichiometric coefficient. Whatever is the coefficient we have, that we bring it down. And number of moles of O2 divided by 3, and number of moles of Al2O3 divided by 2. Now let us find the number of moles of aluminium and O2 based on the weight given. We know that number of moles is equal to mass divided by molar mass. Therefore, number of moles of aluminium is equal to mass given is 81 gram. Molar mass of aluminium is given as 27 gram per mole, and therefore this will be 3 moles. How about O2? Number of moles of O2 is equal to mass given is 128 gram. Molar mass of O2 is 32 gram per mole. Here they have given the atomic mass of oxygen. Therefore, for O2 you have to multiply by 2 because we have 2 oxygen atoms. Therefore, this is 32 gram per mole. Therefore, this will be 4 moles. Let's find out the limiting reagent. Limiting reagent is equal to number of moles of reactant, let's keep it as X, divided by the stoichiometric coefficient of X, and whichever is the smallest out of this. The smallest out of this is the limiting reagent. Therefore, number of moles of aluminium, we found it as 3 moles, isn't it? So, therefore, 3 mole divided by stoichiometric coefficient is 4. Therefore, this is equal to 0.75 mole. Number of moles of O2, we found it as 4 moles. Therefore, 4 moles and the stoichiometric coefficient was 3. Therefore, this will be 1.33 moles, which is smaller, this is smallest. Therefore, aluminium is the limiting reagent in this case. Therefore, number of moles of aluminium divided by 4 should be equated with the number of moles of Al2O3 divided by 2. This is the equation that we should use because our limiting reagent is aluminium. Therefore, we can equate it. Now, let us find the mass of Al2O3. Therefore, number of moles of Al2O3 is equal to 2 times 3 mole divided by 4. So, number of moles of Al2O3 will be equal to 3 by 2 moles. Therefore, mass of Al2O3 is equal to number of moles of Al2O3 times molar mass of Al2O3. Molar mass of Al2O3 is, we have 2 aluminium atoms, therefore 2 times 27, that is equal to 54. We have 3 oxygen atoms, therefore 3 times 16, that is equal to 48. Therefore, this total will be 102 gram per mole. Therefore, this is equal to 3 by 2 moles times 102 gram per mole. This will become 51. 51 times 3 is 153 gram. So that's the mass of Al2O3. Therefore, the correct answer here is 153.